Hey folks, hope everyone's doing okay. Hope first week has gone just fine for you. I know this has been a definite learning experience for everybody. Um, some of the other off topic subjects that we've been dealing with, I don't know if you guys have been having a lot of issues with Google Meet and some of those other types of platforms, and I know I've talked to a few of you guys over that. It's been pretty glitchy for me right now, so I'm going to continue to try it. I've got a couple of other options. We'll see if it ends up clearing that up, and then we'll go from there. I did talk to the tech people today. They decided a long time ago, I guess, that teachers had access to Zoom, but students do not. So I actually had great luck with that when talking to a couple of teachers the other day, and it's unfortunate, but it is what it is. It's our reality right now. All right, so we are going to be moving on to the next topic. Intro to lenses. We've already done mirrors, and we did all of our ray diagrams for those. Luckily, dealing with lenses will not be a huge adjustment from what we just saw with the ray diagrams for the mirrors. So let's go ahead and get into the notes here. So a lens is a device that utilizes refraction to focus light upon a point. Okay, so when this happens, when light comes in, we should know, so if we're looking at this convex lens here, and I'll get into the definition here in a little bit because this definition is somewhat correct, and I'll talk about that here in a few seconds. So as light goes from air to this glass lens and it hits this curved surface, there's going to be a slight bend here towards the normal, because remember, we're going to draw our normal line here. And then there's going to be another slight bend as it goes from the glass to the air away from the normal. Now, what this means is there is a bend in both places. For our purposes, whenever we're doing any ray diagrams, and just remember this for future worksheets, because this is going to happen. I was just redoing the key on a couple of them just to make sure, and sure enough, sometimes the object's bigger than the lens. What I always do is I draw a dashed line right through the center of the lens, and I take the incident ray to that dashed line. So when we're solving thin lens problems, we only have to just focus on the middle part of the lens. Even though there is a refraction that occurs on both surfaces, that would be a real pain in the rear drawing all of these. So we will just focus on the center of the lens only. Okay? All right. Convex lenses. Used to focus light by converging rays on the opposite side of the lens. Okay, so we have a convex lens here. I want to make sure I'm clear up front with this. I know this says converging the rays, and we end up with a focal point over here on the opposite side of the lens as all these rays come through. This is not always accurate though, so that's where drawing the lenses can get a little bit more complex. Most of the questions are going to assume that you have light traveling through air through a glass lens, as this one shows here. When you have that scenario, sure enough, the light will converge. Okay, where this gets a little bit tricky, let's say I have a bucket of water and I put a converging lens that is just an open air-filled space. It's closed off so the water can't get into it. But so you basically have an air lens inside of water. The exact opposite would occur in that scenario, and the rays actually diverge. Okay, so that's going to be on the next video, so we'll talk about that a little bit. So when we're drawing ray diagrams, all lenses, they're glass, we're light propagating through the air. Okay, a concave lens. These lenses are used to diverge the light as it refracts through a negative focal point. Okay, so now we have our double concave, and that's another thing I need to explain here. You will see the term concave. If it just says concave, just assume it's a double concave. But I may give you a plano concave or a plano convex. If I say plano concave, that means the front side of the lens is flat and you only have the curvature on the back side of the lens. Same thing with a plano convex lens. This side would be flat over here, and this side would be the curved side on it. Once again, we'll discuss that in the next lesson a little bit. So notice that we now have a focal point, and the focal point's negative. So just like we did with diverging mirrors, all diverging mirrors, when we plugged it into our equations, we had to use a negative focal point. The same thing is going to happen for concave lenses. Okay, I'll talk about this on a later video, but the way we do this is there are two focal points. Okay, there's a primary and a secondary. So we will discuss that later on. All right, I already discussed this, but both of the descriptions above assume the lens is made of glass and placed in a less optically dense media. Okay, so hence glass in air. If we take this image right here, notice where the focal point is. It's pretty close to the lens. Okay, if we were to place the same lens in water, now the focal point is going to be further out because water has a higher index of refraction. So the difference between the index of refraction of the water and the index of refraction of the glass lens is now less. So what happens here is instead of the focal point being here as it is in air, it's going to shift it out. We have a special equation coming up in the next video for that. Excuse me. All right, this is what I talked about. Excuse me. I promise I don't have the coronavirus. This is what happens when we place the air in a more optically dense medium. So notice that we have a medium with index of refraction of 1.5 and the lens is now 1.0. Now what happens is the focal point comes back here. So since the lens has a lower index of refraction, then the light now diverges even though it's a convex lens. Okay, if I put a concave lens in the same scenario, light would actually converge. So basically what happens is these two diagrams flip-flop around if the medium has a higher optical density than the lens does. Okay, all right. So in the end here, the focal point of a convex and concave lens depends on both the index of refraction of the lens and the index of refraction of the medium. Once again, most of these questions are going to be fairly straightforward, but we do need to introduce the lens maker's equation. So before you open up the next video, go ahead and load up handout 6.25 that I have placed on Canvas. Okay.